Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 7. We're continuing our discussion of trigonometry. Perhaps we should add a question mark. Trigonometry, really? Well, a lot of people know trigonometry involves things like sines and cosines and tangents. And Math with Haas, frankly speaking, I have not seen any of those functions or those things. And yet here you are. You've already done 6 episodes plus 3 programming episodes on trigonometry. Where is the trig? Well, today it is trig time. So, a couple episodes back, we introduced the notion of finding a measurement of an angle using radians, and that was in terms of this ratio of the arc length divided by the radius. So let's go ahead and draw us a picture. So here's our circle, and here's our xy axis. Now here is our r, there's our radius r, and here's our angle theta. Now we need to have a couple new colors. So what we want to think about now is drawing a triangle, right? So if we think about this triangle here, let's use this purple. We can see that for our triangle, we're going to have a x and a y coordinate. So this point right here, actually we'll do it in red. Yeah. So we have this point here. Maybe red wasn't the best choice. That would be a better color. Maybe gold. We'll do gold. Yeah. Okay, we can see that much better. Alright. So we can see that if we make a triangle, that's a right triangle, where you just go straight down from the point of intersection of the circle and our radius after we go out some angle. And then if we go horizontal across, we form a nice 90-degree angle. This is a nice right triangle. And this point is going to have the coordinate x comma y, where x is going to be the length of this segment here, since we're going straight across horizontally. So this is our x, and then since we're going straight up, this distance from the x-axis straight up, that's a distance of y, and so that's why our point is x comma y. Now, when we think about how we defined theta, theta was a ratio of the arc length divided by the radius. Now, since we are thinking about our angles in this manner, we can imagine a larger circle. Okay, so if this is one circle, we could draw a second circle that's bigger, noticeably bigger in this case. And we can have here's the radius, this we'll just call R2. Here's the same angle though. We can draw a right triangle like last time. So this will be y2, this will be x2. Now, when we thought about our theta, it was the ratio of the arc length divided by the radius. Now this ratio was constant. It doesn't matter how big of a circle or how small of a circle, theta was just theta. It's a unitless measurement. Now, this idea we can apply to the sides of these triangles. In other words, so I'm going to put subscript 1 here. So this is x1, y1. So the ratio of y1 over r1, this is going to equal the same ratio as y2 over r2. And similar with the x coordinates, the ratio of x1 over r1, this is going to equal the ratio of r2 over, or x2 over r2. And these ratios will be valid for any angle theta. Similar like what we talked about with arc length over our radius here. And so these ratios, we're going to want to refer to them in a easier manner, and so we're going to give them names. And these ratios we're going to find as functions of our angle theta. So this is where sine and cosine actually come in. So sine, let's write this out, sine, and then cosine. So now we're going to define what sine and cosine are. So sine, we abbreviate with sin. So sine of theta is going to equal the ratio of y over r. So that's the y coordinate over the radius. And cosine is going to be x over r. So this is our first important glimpse at sine and cosine. So what that is saying is the ratio of y over r is equal to sine theta. So in a sense, there's a strong relationship here between the sine of the angle and then the y coordinate of our right triangle, and then similarly with cosine and the x coordinate. And that is something we are going to be using a lot of. Alright, now I do want to make one historical note about this term sine, so I need to take a moment to find that. I just thought of it. Oh, wait a minute, it's in a different edition of my textbook. So we'll go off of memory here. So sine comes from the Latin word for sinus. Let's see here. Let's double check that. Yes, I was correct. So sine is Latin from sinus, and sinus is means like a bend, fold, curve, bent surface. And it also means the fold of, it could also mean like a bosom. So yes, that means a lady's breast. Curve. So that's kind of where the name comes from. And why is this given such a name? Well, let's just say we'll find out when we look at the graph. For now, we'll just claim that the graph is going to be very curvy in a manner like this. And cosine's also going to be very curvy like that. So that's an interesting note. I always thought that was kind of entertaining, that the origins from Latin and sinus, and it has this connotation of the breast and just the curvature. Alright, so coming back to trig. So sine and cosine. Sine is y over r, cosine is x over r. And now, well, we can think of two more ratios here. So we're actually going, or not two more, we can continue to think about ratios. So we could also think about the ratio of the y terms, or the y coordinates divided by the x coordinates. And that is going to give us tangent. I don't know what I'm writing there. Tangent. Alright, let's delete that. Alright, so tangent. We abbreviate this with TAN. So tangent theta is going to equal y over x. So essentially what we're doing is we're taking this ratio of y over r and we're dividing it by x over r, but the r's cancel out, just giving you the x over r. Okay, so that's what this ratio is getting at. And we can think of three more ratios actually. We have cotangent, and cotangent is denoted with COT. So cotangent theta, that's going to be similar, but it's going to be x over y. So it's similar to tangent, but it's x over y. And we can define so if we think about the relationship between tangent and cotangent, cotangent is the reciprocal of tangent. So we can define two more ratios that are the reciprocal of sine and cosine. So if we can define what's called secant, S-E-C, so secant of theta, that is going to be the ratio of r over x, and cosecant, that's going to be the ratio of the radius divided by the y coordinate. So that is going to be our, oops, that's a bad line, undo. So this is going to be the 6 trig functions, and this is going to be what we're going to have fun with for a very long time. Alright, so I think what we'll do is continue this discussion with another video. For this one, we're going to strictly limit to just thinking of the trig functions as ratios, and then we'll start talking about finding values and all that good stuff. Alright, thank you for watching this video of Math with Haas. If you've been enjoying our content, please subscribe, consider supporting us on Patreon. Thank you for joining our math party, and I will see you next time.